Talk about multiplying decimals together. We can come back to something that we have talked about in the past, a couple things we've talked about in the past. First of all, converting a nice decimal into a nice fraction by using the place name. So 3 4/10, we can say, all right, the tenths place telling us the denominator, 2 and 1/100th, the 100 being in the denominator because of the 100 in our place name. And then multiplying fractions, we multiply straight across. So in multiplying straight across, we end up with the 6,834 over 1,000, which we can turn back into a decimal. That's a lot of steps to take care of, so we'd be interested in looking for some sort of pattern that would allow us to more quickly arrive at our answer, and especially maybe avoid any sort of fractions at all if we can. So it turns out that there is a pattern that we can utilize, and that's to work with the numbers as though the decimal points were not present until the very end, where we come back and consider how many decimal places were in each one of our original numbers, add those together to determine the number of decimal places that need to appear in our final answer. So starting at the end of our final answer, we can backtrack and place the decimal point in the correct location. So again, to emphasize what we're doing here, we're going to go ahead and we're going to take the 85.4 times the 6.2. We're going to start as though the decimal points weren't even there. So a version of that, decimal points not present. We'll work through all those calculations and end up with 52948. But we did have decimals in our original numbers, and so our answer in this example is also going to have a decimal point somewhere in there. So we go ahead and look at what's going on. The first number in our problem had one decimal place. The second number had one decimal place. One decimal place, one decimal place. So our final answer is going to have two decimal places, starting at the end of our answer, 1, 2. Fix our decimal point in that location, and we're done. So we'll do a couple examples of this together. A little bit of variety here with the kinds of numbers that we see showing up. So in this first example on the left, 42.65 times 0.804. We're going to start out, we're going to act as though those decimal points aren't even there and work through our multiplication steps. So 4 times 5, 4 times 24, 4 times 2, 4 times 4. Move on, use the 0, use the 8. Bang that out. So 4 times 5, 4 times 6, 4 times 2, 4 times 4. 0 times all that stuff is just going to give us a row of zeros. And then using the 8, we'll come back, 8 times 5, 8 times 6, 8 times 2, and 8 times 4. So with all the carrying and everything in there, we now have our finished rows, and we can go ahead and work through our adding, so adding down the columns. Now, we're done with the actual calculation work, with the exception of figuring out where our decimal point needs to be. So we'll come back and make some comments off to the side. Our first number has 2 decimal places. Our second number has 3 decimal places. So altogether, our final answer would need to have 2 plus 3 is 5 decimal places. Starting at the end of our answer, 1 decimal place, 2 decimal places, 3 decimal places, 4 decimal places, 5 decimal places, meaning that we can write our final answer as 34.2906 6. We do not need that extra 0 at the very end of our final answer. We can leave that off. Same general approach for the other example on the right side of the screen here, 1,247 times 0.0041. So we begin again by just multiplying as though the decimal points are not present. So 1 times 7, 1 times 4, 1 times 2, 1 times 1. 4 times 7, 4 times 4, 4 times 2, 4 times 4. And then go ahead and add down the columns. So our calculation work is complete with the exception of figuring out where the decimal point is in our final answer. So we come back to the original numbers that are in our problem. First number is a whole number. It does not have any numbers appearing after a decimal point. In fact, there is no decimal point that directly appears. So we can say that that first number has 0 decimal places appearing in it. The second number has 4 decimal places. So in our final answer, 0 plus 4 is 4 decimal places. Starting at the back end of our answer, 1, 2, 3, 4, meaning that our final answer is going to be 5.1127. Now, following from multiplication is division. Division has 2 different kinds of situations that we would need to talk about. One of them's nice, one of them is not so nice, but I got some cute little reminders to give you to help you work things out. In this first example, what we've got going on out front that is nice is just a regular old whole number. There is no decimal point in the number that's here out in front of our long division symbol. There is a decimal point only in the number underneath that long division symbol. So you could say very cutely that if there is a decimal point in the house, raise the roof. Take that decimal point and raise it straight up so that it pops up on top of the long division symbol. Then, for the rest of our work, we're going to actually go through our division steps as though that decimal point is not even there anywhere in the problem. So all of our work is just lined up based on the way that we've done all of our past division problems. 82 goes into 3, nope. 38, nope. 385, yes. It goes in 4 times. So this would definitely be the first spot that we need to fill in. Notice that I can go and backtrack and fill in a 0 in front of the decimal point if I feel so inclined. So I do my little subtraction work. Carry the 4 down, 82 goes into 574 7 times. Get my remainder 0, and I'm done with my work. My answer is the decimal answer that's up on top, 0.47. So I do a couple of examples. Let's do one that has a little something extra to it beyond just what we've mentioned here about dividing. Start out with this 8 divided by 25. We need to identify the correct number that goes in front of our long division symbol, which is the number 25. 8 goes underneath, and this doesn't give us anything to work with so far, so I want to throw that example out there so I can make a few extra comments for situations like this. If I don't already have a decimal point and I can't make any progress, what I can do is I can take the number underneath the long division symbol, put a decimal point in there, and begin putting in extra zeros after it, as many extra zeros as I might need in order to complete all my division steps. So in this particular case, we'll start out by putting in a decimal point and an extra 0. That'll get us started. Before we actually start doing any of the division steps, we want to remember that if there is a decimal in the house, we want to raise the roof. So we're going to take that decimal point and raise that directly up so that it will appear above our long division symbol. Now at this point, I can go ahead and proceed with my division steps, remembering that if I need to, I can continue to add zeros here underneath. 25 goes into 80 3 times. 3 times 25 is 75. So I have a remainder for the moment of 5. I want to go ahead now and put an extra 0 in here so that I can drop that 0 down and ask myself how many times 25 goes into 50. Well, 25 goes into 50 2 times, meaning that when I do my subtraction work, I get a remainder of 0. Remainder of 0 has always meant that we can stop our division work and we will have our answer. Our answer will be what is up above our long division symbol. So again, we can write in 0.32, or we can also write in 0.32. Either is acceptable. Now what happens if we have a decimal in the number that's out in front, and possibly also a decimal in the number that's underneath? So something like this example here. Decimal number out in front, decimal number underneath. This is not so nice for us, and we don't have a nice way of just immediately going into our division work. Instead, we have to do a little bit of change. The cute phrase here is, if there's a decimal to the side, slide. Well, there would still be a decimal to the side, so slide again. Now there would no longer be a decimal in the number out in front of our long division symbol. So we could take that decimal point, which is underneath, there's a decimal in the house, raise the roof, punch that straight up, and then go ahead and work through our division steps. 83 goes into 406, 83 goes into 747, get our remainder of 0, our answer up on top, 4.9. So we take a look at an example to work together that uses this. Again, it's important for us to identify the number that would go out in front of the long division symbol. With that traditional division, the number that goes out front is the second number. The number that goes underneath is the first. Meaning that we would have a division problem where there is a decimal point in each of these. You could say there is a decimal to the side. So we want to slide. Now if we do that one time, we'll see that there is still a decimal to the side. So we're going to have to slide, slide. There would still be a decimal to the side, so we would have to, once again, slide, slide. Finally, now we would have a problem, and we'll go ahead and rewrite it for the sake of neatness, where the number out in front is now that much nicer to use, whole number of 47. And the decimal underneath is in between the last pair of 2's. Notice that I've also made the decision here, because it would be unusual and even a little awkward. I've taken this 0 and thrown it away. It's not something we would need any longer sitting in front of the 1. So I go ahead and throw it away, and I have numbers that are much more familiar to me to work with. So now we have that situation where if there's a decimal in the house, raise the roof. So take that decimal point and move it directly up so it appears on top of our long division symbol, and work through the rest of my steps as though the decimal points are not even there. So 47 goes into 1, no. 47 goes into 12, nope. 47 goes into 122, yes. 47 goes into 122 2 times. 2 times 47 is 94. Do a little subtraction work here in order to get our $28. Carry the 2 down that we haven't used here, so really we're looking at it, even though the spacing is a little off, 282. 47 goes into 282. Well, 6 times 47 ends up giving us exactly that 282. So, remainder of 0, telling us that we're done with our work. So our original division problem now has an answer that we were able to calculate from a much nicer looking division setup. And that answer would be 2.6. At this point, what we can do now is take the discussion of adding and subtracting, multiplying and dividing, mix everything together and revisit the order of operations. Thankfully, the order of operations is not changing from the 2 previous times we visited it at the end of our Chapter 2 work and at the end of our Chapter 3 work. So now here at the end of Chapter 4, we're right back to the order of operations, and it is still the same. So, same sort of reminder as we've used before at the end of Chapter 3 that we had discussed for the first time at the end of Chapter 2, and the importance being that we go through and read and decide what we do first. So, the P for parentheses also means that we want to take a look for any sort of brackets, regular brackets, curvy brackets, absolute value bars. So we do see a set of parentheses, but we also see, maybe a little bit more importantly, a set of brackets with inside of that a set of parentheses. So really our anal retentive first step is to work with this set of parentheses, and we'll leave the other ones alone for a little bit here while we begin with 2 minus 1.6. So anytime we can use money, that's handy. So I can look at this as 2 minus $1.60. I could also just think of it as I have $2. I owe 1.6 or 160. Again, the money version helping me kind of make sense of that. And so my answer, I want to recopy all of the rest of what we have appearing in the problem so that I can read what appears and decide what to calculate next. Well, since we're still inside the brackets, might as well go ahead and finish that up. So we've got the 0.4 divided by the 0.8. Underline that in green, and go ahead and move off to the side and say, all right, so if we're going to go work that out, the 0.8 is out in front of our long division bar. The 0.4 would be underneath. If there is a decimal to the side, slide, meaning that the 8 or 0.8 out front turns into an 8, the 0.4 underneath turns into a 4. That's not quite enough yet for us to get started, so we go ahead and put the decimal in after the 4 and throw in an extra 0 so that we have a little bit of something to work with and make progress. But now that that decimal point is underneath, well, there's a decimal in the house, so raise the roof. Take that decimal point, pop it straight up. Now ignore the decimal points. How many times does 8 go into 40? Well, it goes into 45 times. So the 5 goes after that decimal point. We get our remainder of 0. So we're done with that and have our answer for that part, 0.5. Recopy all the rest of the work that we have yet to use. Now we come back to that first set of parentheses we commented on before. We said we're going to put that on hold, and now it's time to go ahead and use that. So go ahead and think about money. Well, this is nice. We have 12, we have 2.4 or 240, so a very direct adding. So 14.4. Again, recopying all the rest of the work that we have yet to touch. And asking ourselves now, based on what we read, what are we going to do next? I have a power of 2, a division, and a subtraction. So the highest priority is that power. 12 squared is 144. And again, recopying the other steps, or excuse me, the other parts of the problem that we have not used yet, so that we can figure out our next step. Reading this again, we have division, we have subtraction. According to our order of operations, the division is the next part that we do. So we move off to the side where we have the 14.4 going out in front of our long division symbol and the 144 going underneath. We have a decimal to the side, so slide, slide. Hey, how do I slide? There's no decimal point underneath. Well, I throw one in there and then go ahead and slide it. Well, as soon as I do that, that's going to mean that out in front, I have a whole number 144. Underneath, if I've slid the decimal point to the right, I would have created an empty spot that I need to fill in with a 0. And we'll see if we need to keep that decimal point in there and put any extra zeros in as we begin working this out. 144 goes into 144 one time. My remainder of 0. But I do want to remember my basic rules for division. I'm not done yet because I haven't filled in what is above my very last number. Well, again, empty spots get zeros. So I fill in that with a 0, meaning that my division problem here is giving me an answer of 10. So the last thing for me to complete here, 10 minus 0.5, or 10 minus 50 cents, $10 minus 50 cents, $9.50, aka 9.5. So final answer here, 9.5. Even though I haven't beat you up with it, notice that. Same order of operations as we were working through. If the decimal points hadn't been there, we still would have worked things in the same sort of order, because the order of operations is the same as it was at the end of chapter 3 and the end of chapter 2. So thankfully there, nothing's changed. We're just incorporating our new rules for how we handle adding, subtracting, multiplying, and dividing with decimal numbers.